So Sujadin sir, can we start?
Good morning, everyone. Shall we start, ma'am? Kanchana, ma'am, Saraswati, ma'am,
Yes.
and yeah,
Yes, yes,
Prabhavati,
yes.
ma'am.
Yes, sir.
Yes, sir.
We
Right,
can
ma'am.
start.
Sure. Right. Good morning to one and all present here. I am Dr. N. Sujauddin, Assistant Professor, Department of CSC. On behalf of the organizing team of ICCIDS 2022, I take immense pleasure in welcoming you all for the third session of paper presentation. Congratulations to the author for their fruitful contributions to research and getting an opportunity to present it in this esteemed conference. It is my honor and privilege to welcome the jury panel members, Dr. R. Kanchana, Associate Professor, Department of Computer Science and Engineering, Dr. S. Saraswati, Associate Professor, Department of Computer Science and Engineering, and Dr. B. Prabhavati, Associate Professor, Department of Computer Science and Engineering, who have graciously accepted to act as session chairs for ICCIDS 2022. It will be a huge opportunity for the researchers to present their work to the eminent panel members, whom with their in-depth knowledge on diversified areas like big data analytics, IoT, network security, cyber forensics, machine learning, deep learning, and image processing are sure to give positive suggestions and feedback to their research work to the next level. We have some guidelines to be followed. The presentation time for the participants is 8 minutes. Discussion with the panel members is 3 minutes. So I request all the authors to adhere to the timings. Without further ado, let's begin the session with the paper ID 15 titled Counting Number of People and Social Distance Deduction Using Deep Learning. I call upon the authors Dr. PCD Kalaivani, M. Abhita Lakshmi, B. Bhuvana Preeta, R. Darshana, M.K. Dharani to present their work. Go to the session chairs. Authors?
Yes, sir.
Yeah, you can share your screen
So-
and start the presentation.
Yeah, sure, sir.
Yeah. By the time, shall I request all the participants to switch on your videos to take a photo shoot? I'll just take a snapshot of it. Is it possible?
Now screen sharing is
Screen, yes, ma'am. Kalaivani, ma'am, can you just stop the screen sharing if you, yeah, just for a minute, ma'am. Yeah,
Sorry, sir. Like,
Yeah, no issues.
our guide is like, sorry for that. Like, our guide PCD Kalaiwani ma'am is not here. Like, so myself and Darshana, we both are students, so we are going to present the
Yeah,
conference.
fine,
So,
ma'am.
yeah.
So before you start sharing the screen, I would like all the participants to switch on the video to take a photo shoot.
Okay. So,
Right.
sure.
Participants, please switch on your video.
Sorry, sir, you're on mute, so we can't hear
Sorry.
you.
Okay. Yeah, I request all the participants to switch on your video. Right. Thank you.
So, can I start
Yeah.
the presentation?
Yes, Bhuvana Preeta, you can share your screen and start the presentation, ma'am.
Yes. So, is my screen visible, sir, to everyone?
Yes, it is visible, Pa.
Thank you, ma'am. So, over to you, Darshana. You can start now.
Yeah. So good morning to everybody present here. It's a privilege to present a paper amidst such audience and jury members. So we have started a project with the title People Counting and Social Distancing Detection. It was done by myself and my fellow mates, Bhuvana Preeta and Amita Lakshmi, and it was guided by Ms. ICCIDS Kalaiwani, our assistant professor in our college. Next slide, please. So basically, when we were given an idea of project in our final year, we were thinking about a variety of options. But at that moment, what struck us was the happening pandemic COVID-19. It really affected our lives to a very great level. So we thought of helping the people with our project in some kind of way. So we got an idea to actually detect people who are not maintaining social distancing in a close circle. So to commence with, the generation of coronavirus was reported in December 2019 by China, and it's been continuing and it's kind of deteriorating now. At most all precautions are taken to limit the spread of infection. Deep learning-based model system is designed in a manner to alert the people to the social distancing along with the total amount of people in it by minimizing the proximity of human physical contact in crowded public places or covered places. Social distancing along with the total number of people have now claims to be more important to stop the spread of virus in the pandemic situation. So I personally believe even now, in the current situation, social distancing is the first and utmost priority we have to take to stop or completely eradicate the COVID virus. So we are really happy about we have done a project on this. Next slide, please. Problem statement. The problem was to count the number of people in open or in a closed space along with the social distancing during the pandemic situation to ensure the limited count in the public places like malls, shops, theaters, etc. to alert the people to an alarm by counting the number of people along with social distancing. Next slide.
Ma'am, Kanchana, ma'am. Sorry for the interruption.
Yes,
Ma'am.
Prabha.
Ma'am, we can go straight to the proposed system, ma'am. When they are discussing about the result, they can compare with the existing, they can tell what is the difference between proposed system and existing system. And there they can mention research gap, ma'am. Otherwise, they will not be able to finish within 8 minutes.
Yes, well taken. The authors, please ensure that you present your work within 7 minutes.
Sure,
Right
ma'am.
away, they can
Okay,
go
ma'am.
to
Yeah,
proposed
sure.
system. They can go to proposed system, and you have to tell how you have implemented, how good your proposed system with respect to existing system, and then the result analysis. That's all.
Okay, ma'am.
No
Yeah.
need to hear about a lot of literature survey and all. Otherwise, you will not be able to finish. Yeah. Straight away, go to the architecture of the proposed system.
Yes, ma'am. So in the proposed system, we just used to count the number of people present in the particular
Go to the
area, no matter
architecture,
it's
ma'am.
open or
Do
closed.
you have a
We
diagram?
have
The next slide.
added the diagram here now.
Go to the next slide. Go to the next slide. Go to the next slide. Next slide.
Yes, ma'am.
Go to the architecture diagram.
Ms. Bhuvana, actually,
Ma'am,
ma'am
we
is
haven't
asking about.
added the architecture diagram in the presentation, ma'am.
Oh, I see one architecture diagram in your paper.
Yes, it's there.
Yes, ma'am. That
But
we
you're
have
not
added
including in the
paper,
presentation.
ma'am.
How come? That
That
is
is
the
what we
proposal,
have
right?
in
Your
this
proposal, your solution proposal is your architecture diagram, is it not?
Yes, ma'am. That is what
Okay.
we are trying to explain in the words, ma'am. Like rather than like we have already added in the paper, so we thought like we can explain those things in a point, step by step in the
See,
points.
whatever you want to explain should be coming in the slide. We cannot go back to the paper, refer something and hear your words, right? Presentation should include the proposed solution architecture. It's all right. Now you tell us, go to the modules, the previous slide.
Ms. Bhuvana,
Somewhere you have written modules.
yeah, you can go to your modules and from there on you can continue with the.
Yeah,
Yes, this
from
one.
here
Thank you.
you tell.
Okay, ma'am. Yeah. So in our proposed system, we have a 4 modules. One is like people detection, other is social distance detection, and counting number of people, and restriction module. We have separated 4 modules. In the people detection module, it's like we are using the pre-trained YOLO detection model with a core data set, and it consists of like different using that pre-trained model. We detect in the frame which we are going to input to our system. So from that, we will be we will be calculating the Euclid between the peoples by taking the centroid of the. So by calculating the Euclidean distance, we can we can calculate the distance between the centroid of the 2 people. So from that, we can the values is overtaking mentioned distance or not. So for that, we are calculating the distance in a pixel. So here is like we are calculating Euclidean distance. So that is using the YOLO detection model, which is a pre-trained model with the COCO data set. So to detect people inside the frame and alert them. So counting the total number.
Not audible.
And
there is some break of
is it
voice.
okay now?
Breaking.
There is disturbance in the voice. We are not able to get it properly.
Is it okay now, ma'am?
No, okay.
Okay, sorry for that interruption, ma'am.
Okay.
So to detect the social distance between 2 people, we are using that like we are using the inbuilt method such as like is close. So from that we can pass the we can pass the distances which we calculated by the Euclidean distance. So from that we can get that like if the peoples are close to each other, then we can like using that method, inbuilt method, we can get like if the people are exceeding the distance, so we will be returning true. So which means like they are exceeding the distance, so they are in the danger zone, which is like they are not maintaining the social distance. So then we are counting the number of people in the frame to maintain the crowd in the particular area which we are going to provide. And in the restriction module, we'll be providing an alarm sound to indicate the person, like you are exceeding the social, I mean, you are not maintaining the social distance. So for that, we are providing the alarm sound.
Yes, what is the result? What is the result of this?
Result means, ma'am, we are passing the video. So the video is like, we have taken the video.
Accuracy of your system. What's accuracy of your system? How will you compare with the existing system? Have you compared it or not?
So ma'am, existing system is like they have in the existing system, they are just detecting the people, whether they are maintaining the social distance or not. So that is the one thing which is an existing system. In our proposed system, we are like, in order to maintain the crowd in the particular area, we have added the counting. We have added the total count of people in our proposed system. And also to alert the people, we just need to provide something sound like alarm. So we have added those two features in our proposed system, ma'am, with respect to, comparing with respect to existing system.
In a crowd, how will you be able to identify a person and say that you are not maintaining social distance?
So for identifying the people, we are just using the COCO data set and the YOLO pre-trained YOLO detection. So from that, we will be COCO data set is like consists of the different types of objects. So from that, we'll be getting, we'll be having some, like using the convolutional neural network, we'll be training our model. That model is trained. So from that is like, we'll be passing an image. So it will assign some value to that, like class probabilities for all the images. So it will assign that value by detecting the images. So from that, we'll be getting the object people alone from the frame. After that, to detect the social distance between them, we are just calculating the Euclidean distance by getting the centroid of the peoples. Once the people is detected, we'll be using the bounding box to make sure that is a people. Then after that, like we'll be taking the centroid of the people, which is the centroid of the bounding box. So if we take that centroid, we can calculate the Euclidean distance, ma'am. So from that, we can maintain that, we can say that you are crossing the social distance.
Go back and see this answer. Actually, I've asked, how do you specifically point a person that you're not maintaining social distance? Please go, answer this question later on. You just go and think. That's it. You can continue if there is anything.
Okay, ma'am. That's it from the modules.
Not from modules alone. So you have remaining slides to show?
We have some outputs, ma'am, results.
Okay. Okay. Okay, next.
So this is taken from our college video. We have taken to college and have checked that video into the.
Okay. Okay, go to the next one. This is real-time video. Next. That's it.
Yes, ma'am.
But there should be some. Yes, ma'am.
Yes, ma'am.
What you have presented is you are showing a crowd scenario and you have detected the object.
Yes, ma'am.
Now you are not telling us very clearly how you will be informing an individual person that he is not maintaining social distance. And you are also saying from existing work, that is in addition to the existing work, what you have added is only counting the number of persons and alarming a person. So counting the number of persons, there are lots of challenges. So if the person is not visible fully, are you able to count? What is the accuracy of your system in identifying the persons? So once you identify, there's nothing, just count. Identification is challenging. Counting that is not, it's simply taking into that image into account, right?
Yes, ma'am.
Hmm.
So by individually, like we are just we'll be providing the alarm sound if one or two, like 1 or 2 or 2 to 3 violates the social distance, ma'am. So that is uh, we'll be providing to that total area,
No,
ma'am.
you need to tell us technically what is your CNN doing, how it is able to detect
YOLO.
the objects, and what is the input to your CNN, what is the output, and the characteristics of your data set. So more technical details are missing. So please go back and try, you note down our queries and try to address this in your paper. Okay.
Yes, ma'am.
Okay. But I can tell you whatever problem you have taken is very important. Then this is an important problem to solve.
Yes, ma'am.
So please continue working on this problem, but you need to really bring us the technical details of how the CNN is able to detect the crowd, detect
Yes.
the people. Okay. And
Yes,
there are
ma'am.
lots of challenges in detection itself. So what are the challenges and how each challenge, at least one challenge you identify and explain how it is overcome or how it is met in your work. Okay.
Yes, ma'am.
Ma'am, adding to that, when I go through their paper, there are a lot of some small mistakes, like the spaces and all were not proper. Like after dot, there is no space. After comma, there is no space. Conclusion, they have written one page. Then the organization of the paper, they have to look. They have to, relook at the organization of the paper. Like one paragraph, they have written as a section like that, and then in the evaluation result they have written YOLO V3 without TL, with the TL, but there is no description in the paper what is TL, what with what they are
Yeah,
comparing.
I noticed that.
all
The
those
TL
things
they
are
have
there
not explained.
mentioned. Yeah, those things are there, and the figures are also not not
We're not,
referred in the text at all. So when I go through the paper, if to understand what they have what they're trying to come out with that figure, I'm not able to get it. So those things, a lot of things are missing in the paper itself. I don't know how they are going to correct it right now, but then
No,
these
no,
are all the mistakes.
we will encourage them to correct it. All
Yes.
the figures and all the references must be cited in the
Paper
contents in
yeah.
the paper. Okay.
Yes,
Okay,
And
ma'am.
if
Bhuvana,
references, the journal name, the volume, number, year, everything should be there. So just to carefully look at, there are so many references without the journal name, without the year. Are you getting Bhuvana?
Yes, ma'am.
Students?
Yes, ma'am. Yes, ma'am.
All papers, the format should be according to IEEE standard. Okay.
Yes, ma'am.
Or you would have been given some guidelines to prepare this paper. Please follow that and prepare this reference.
Yes, ma'am.
And
Okay,
only one paragraph under this section is not correct. And one more serious mistake is in figure 1, the architecture. You are showing testing and training in the same flow. Actually, training is a different flow, testing is another flow. So this architecture diagram you modify to show clearly what is happening in training and to show clearly what is happening in testing phase. Okay.
Okay, ma'am.
So I hope you noted down all the corrections. So please correct, revise the paper and submit. And the conference organizers will guide you further on submission.
Yes, ma'am.
Thank
okay,
you.
Bhuvana, from my side, the question is, you are saying that you are taking a video and you are separating it into frames. So which particular frame you will be considered? The people are in moving, isn't it? So in
Yes.
that time, which particular frame you will be considered for your processing? So those things also, it will be better if you are addressing. along with the technical background.
Yes, ma'am.
Yeah.
Yeah, thank you. Thank you, students.
Yes, yes, ma'am.
Thank you.
Thank
Thank
you, ma'am. Thank you, authors. So the next paper, I call upon the authors of the paper with ID 25, titled A Progressive Approach of Designing and Analysis of Solar and Wind Stations Integrated with the Grid Connected Systems, to present their work. The authors are N. Bala Venkadamuni, Dr. S. Sasikumar, Dr. K. Hussain, Mr. K. Meenendra Reddy, to present their work. Thank you. Authors. Paper authors of paper ID 25. Is there anyone in the meet?
I don't think they are available.
Yes.
Right, ma'am. Yeah,
We'll
we'll
go
move
to
on
the
to the
next paper.
we'll move on to the
Yes.
next paper. We will come back later if time is there. Yeah. Next, I call upon the authors of paper with ID 39, titled Dataset Creation and Empirical Analysis for Detecting Signs of Depression from Social Media Postings. So the authors are Kayalvili Sampath and Dr. Tenmuli Durairaj. Authors, you can share your screen and present your work.
So much of noise disturbance.
Yeah, yes, ma'am. Ms. Kayalvili, actually your audio is not clear. There is background noise coming.
1 minute.
Can you correct it? Yeah.
Is it okay, maybe fan noise. You can switch off for some time.
Yes, ma'am. Now it is clear, ma'am. Yeah.
To some extent.
Yes, yeah, ma'am, sure.
Oh.
Please switch off the fan.
Yes, ma'am. I will actually did it. Is it okay now, ma'am?
No,
There is
no, it is
some noise is coming.
annoying.
Some noise. I don't know what it is. It's not a fan sound, maybe, ma'am. Ah. Oh.
Ma'am, is it okay now? Ma'am, is it okay now?
Oh, sound varudhu. Still noise is coming. Wait, okay, ma'am. We'll go ahead with noise. What to do?
Is it
Yeah,
okay now?
really, காது அப்படியே இதா இருக்கு. But Kayalvili is in
Ma'am?
HPC lab only, right?
No.
No, ma'am. Oh, there is no noise. You can continue. Is it
Now
okay
there
now,
is no
ma'am?
noise.
Okay,
She
ma'am.
didn't connect. I think she didn't share her screen still.
But,
Kayalvili, you can share your screen and start your presentation. Yeah.
Yes.
Appa, no noise.
Thank you.
Is it fine, ma'am? Is
Yes.
everything
Yeah, it's
fine?
clear.
Correct.
Yeah, thank you. So, good morning, everyone present here. I am S. Kayalvili from CSE Department of Assistant College of Engineering. I am doing my PhD under the guidance of Dr. D. Tenmuri. I am here to present our work about dataset creation and empirical analysis for detecting signs of depression from social media postings. This is the flow of our work. And coming to the introduction, according to psychiatry, depression is a common and serious mental illness that negatively affects the way one feels, thinks, and acts. And it is estimated by the Global Health Data Exchange that 280 million people worldwide are affected by the depression, and it has to be observed and treated at a very early stage to avoid serious consequences like suicide attempts. For detecting depression, there are many ways like clinical interviews, monitoring their facial and speech modulation, analyzing their behavior, conducting some physical exams and evaluating it using the depression scales and calculating their depression scales using some audios and videos. But all these methods involve some involvement of the individual or discussing about their feeling in person. That is the one drawback in the ways of detecting. On the other hand, when we look upon the social media, it is a highly emerging one with a considerable rate of increase in social media users, and it is a very comfortable, it is considered to be a comfortable virtual platform to express our feelings, and thus social media platform can be considered as a source to analyze a people's thought and can also be used for analyzing the mental health of an individual. And thus, we aim to use the social media text for analyzing the mental health of the person. And we aim to create a data set to do the same. And in the related work, we have many works which discusses the same thing, but they are not detecting any levels of depression. They detect only the presence of depression. And so we propose to create a benchmark data set that not only detects the depression from social media data, but also categorizes the level of depression. And also, we tend to develop some baseline models using traditional learning algorithms and also analyze the effect of augmentation in the data that we collected and created. So, for coming to the first module of the proposed system, it is a data, which is a data set creation. We tend to create a benchmark data set for detecting the depression levels from the social media postings level. So, in that work, the first initial step is we are going to collect the data and we are going to annotate the collected data, and we are going to calculate the interrated agreement among the annotations that were done, and we are going to form the corpus. Initially, for collecting the data, we are going to choose a social media network, which is an open source platform. For this work, we have chosen Reddit, which is an open source platform, and it has since it has more textual data, we have chosen it. And within the Reddit, we have many subreddits upon which we choose the subreddits like mental health, depression, and loneliness, stress, etc. Since our area of interest is to detect the mental health, and from those subreddits, the particular topics like post ID, title, text, URL, etc. are collected using the Python Reddit API wrapper, and then we are going to export the collected data into a CSV format like this. So this is a sample Reddit posting that we have collected. It will have a title, text, and etc. And after collecting all such data, we are going to annotate it. For annotation, we took the help of two domain experts, and based upon these annotation guidelines, we annotated every instances of the whole data set that we have collected. For example, if the statement express more than one disorder conditions, or if the statement explain about any history of suicide attempts, then the data is annotated as a severely depressed one. Likewise, every data instances are annotated, and after annotating all the instances, interrated agreement is calculated to denote the consistency of the labeling according to the annotation guidelines. The kappa value is used to find, and the kappa value is found to be 0.686, which is very substantial according to the Landis and Koch table of agreement. And the mutually annotated instances were used or utilized to form the corpus. And forming such corpus, this is the whole statistical analysis or statistical details of the whole data set, in which out of the whole 20,088 data instances that were collected, 16,632 instances were mutually annotated, and they were considered as a data set. This is a class-wise distribution of the data set, in which we can see that the moderately depressed class is overpopulated in the whole data set with about 10,494 instances. And coming to the second module of the whole proposed work, it is an empirical analysis in which we are going to build a baseline models to evaluate the data set. The first, it is done by a series of process. Like first we will pre-process the data and we will extract the features, and then we will classify using the traditional classifiers. We are also going to analyze the effect of data augmentation in the same data set. So in the pre-processing step, the title column and the text column of the instances that were collected or combined together first as a single text data. And the text data is initially cleaned by converting everything to lowercase and removing the unwanted punctuations, web links, HTML links, etc. And after cleaning, the instances are tokenized and stemmed and then lemmatized, and then they are used for further processing. In the process of building the baseline models, initially features were extracted using 3 different vectorizers like word-to-vec, TF-IDF, and GLOW. And it is classified using 11 different classifiers, namely Adabus classifier, decision tree, KNN, linear deterministic analysis, etc. So on the total, we have 11 different models, and all these models were trained and validated using stratified k-fold sampling, which is a cross-validation process. Since we do not have any explicit split as train, test, and development, we went for the stratified k-fold sampling, and we took 10 folds, and the performance is measured using F1 score. And this is the result of the whole baseline models in terms of F1 score. In this graph, the x-axis denotes the different classifiers and y-axis denotes the performance values. And from the graph, it is clear that the GLOW with the MLP, which is a multi-layer perceptron and random forest, found to be performing very well with the F1 score of 0.647 when compared to the other systems. Since they are both the classifiers are having equal F1 score, we took into account the accuracy according to which the GLOW with RF found to be performing better. So to deal with the data imbalance problem, as we saw earlier, the data is overly populated with moderately depressed instances. So for to deal with the same problem, we did data augmentation using synthetic minority oversampling technique, which is SMOT. So SMOT will be applied after vectorization. So initially we will do the vectorization process, and after that we will apply SMOT to the vectors, and then we will classify using the same set of 11 classifiers that we saw here. And after that, the performance is again measured, and this is the result of the whole performance. And from this graph, it is clear that the word-to-vec with random forest achieves a good result with a F1 score of 0.877. And we can also see that data augmentation have improved the performance, both in the term, actually it is shown, only F1 score is shown here, but and also in terms of accuracy, the performance is very good. And coming to the analysis of the result, we have to measure the significance of improvement in performance by incorporating data augmentation. We did the analysis using BCR metric, which is calculated by dividing the F1 score of proposed model with data augmentation and the F1 score without augmentation. So in general, if the BCR value is greater than 1, then it is found to be significant. Since we can see all the values are greater than 1, the performance improvement in performance of data augmentation is significant with respect to F1 scores.
Kyle Viri.
Yes, ma'am.
You said there are 11 classifiers.
Yes,
but
in
that slide you said that there were 33 models built.
Yes, ma'am.
With 11 classifiers, you built 33 models.
With 11 classifiers and 3 different vectorizers, ma'am. TF-IDF, GLOW, and word-to-vec. So
3 different feature selections.
Feature selections.
Okay.
So there are 33 models in
Understood.
total.
Understood.
Okay.
Next, you are getting annotation from the experts, right?
Yes, ma'am.
So domain experts. Yes, and when you are taking the data sets itself, why didn't you consider balancing of the data set? You could have retrieved properly the depressed, low level depressed, high level depressed. Why you have to collect the data without balancing, and why should you augment that data and you have to go for modeling again?
Ma'am, shall I add this, ma'am? Actually, we are collecting data for a period. So it consists of several postings. So as a whole postings, we give it to the experts.
Domain experts.
Yeah, domain experts, and they will annotate each and every postings what it contains.
After annotation, anyway, we will have the freedom of taking the data set
before
we give it to the model, right?
We can do that. In what way we can do? Either the value, that is the class with lesser value to be. We need to keep on finding for the more what to say. If a class has very lesser count, we need to find for such
instances in the text. So that is very tedious process, and this is the general way of doing annotations. So we have to take blindly, will be taking a large corpus and will annotate everything. If data imbalance is there, we need to rectify that by means of some techniques only.
You can straight away go to model building, right? By then itself, you can analyze the data set for the class. Usually we will do like that. So we will do exploratory data analysis to see whether it is balanced or not. And after that, we can go for building the model. Why you have to waste time to build 33 models and go ahead with comparing data augmentation without
that we can do. That is initially to check whether
initially we have to check, right? So that is my concern. The next one is there is an expert. Okay, there are two experts and you have interlevel agreement to compare their thing, and you have commonly agreed data set, you have pulled it already. So why you think that there is a support, that there needs to be a support of ML models in order to what is it you are doing with ML model right now? Since you are getting annotation from the experts, what do you want to do with ML models?
If we
what
go
is the
for
connection between these two?
If we go for a supervised learning, we need label data. For that, for getting the label data, we use the annotators. And after, once we get the label data, we train our model so that any unseen samples we give, like in reality, if we get any, like if I observe your social media postings, which is very new text, which is not there in our model. So if I give that postings to my model, it tells whether possibility of depression is there or not.
I got the point, but why you have to say that this is a data set creation? So any data set which is taken from real-time data can be annotated by manual expert, and it can be verified with ML model, could be released as a data set, new data set to the community.
Actually, whatever the data set currently available is not detecting the levels of depression. It is
understood. Yeah, understood. That is why you are going for annotation. What is my question is, any data set that we are coming up with real time can be verified with ML models, and it could be released as a benchmark data set in general.
Actually, if you, when, how will you annotate that, ma'am? Because we need, if you want to apply to the supervised models, we need the labels.
ஜெனரலா கேக்குறேனா, இப்படி பண்ணா அது ஒரு பெஞ்ச்மார்க் டேட்டா செட்டா ஆகுமா?
இல்ல, அது வந்து அவங்க காப்பிரைட் வந்து, because originally they collected data from some source.
Yeah,
so we cannot claim.
We propose this data set as a benchmark data set that needs to be verified, right?
Yes. Actually, for this reason, what we have done, we have released this data set in a shared task. So there, multiple participants have participated that, and a lot of work has been done, and now it is considered as a benchmark data set, and it is released globally. So anyone can work on it, and they try to improve it.
And the last question is, if at all data augmentation, gives a good accuracy, why should we have this ratio BCR, where without augmentation and with augmentation? Because with augmentation already we have good accuracy, right? So why you have to bring this metric at all, BCR metric?
Just to prove the significance of the improvement, ma'am. We can manually see,
that is quite visible. When you say that without augmentation it is 77, with augmentation if you say 87, it is quite visible, right?
Yes, ma'am.
Ma'am, actually,
I have a doubt. That is
actually, this kind of BCR test or statistical test is help to show the significance of the improvement. For example, for few models, the data augmentation may give better result. For example, some 51 models have given good result for data augmentation, and only with a few difference, some models may not give. Actually, only when we plot this kind of statistical analysis or BCR metric, we come to know that if how many of them have fall under the required category. According to that, we can say that the improvement is significant or not. There may be improvement.
Okay. So you are checking across different models.
Yeah.
Got
yes,
it. Yes. Okay, I'm done.
Okay. Any other questions, ma'am?
And
there were lots of questions, and we are running out of time. Thank you, Kailvali. It's a good work. We will move on to the next bit.
Thank you.
Thank you, ma'am.
Thank you, authors. Thank you, panel members. So next, I call upon the authors of the paper titled.
Yes, good morning. I will
Yeah.
try to share my screen.
Yeah. Factors influencing the helpfulness of online consumer reviews. Authors are Sudarshan Jayasingh and Thiruvengadam Tyagarajan. Over to you, sir. Please.
I think we are running out of time, so I'll make it very short. Good morning, everyone. Wonderful for the organizing committee for making all the arrangements. A lot of information is shared. My topic here is about the helpfulness of online consumer reviews. I think we are familiar with a lot of reviews, and the research shows that a particular customer for certain products, they will depend more on reviews to take a decision, and the number of reviews which is being posted is in like Amazon and all, it's been millions, and they read 3 to 4 or 5 reviews. Okay, so the number of reviews they're going to read is very less, and if they read something reviews which is incomplete or not there, they may take a decision not to buy and all those things. So what Amazon as well as a lot of companies, the websites, the reviews have been posted, they make sure that good reviews, good here, it means that it can be positive or negative, which will help the customers to take a decision. So they came out with the helpfulness. You can see it here that whether this review is helpfulness. So what factors will influence the consumers to select the helpfulness of the review? That is my topic here. I think I mentioned about many people, I think 93% of the customers read online reviews, and there are overload of reviews have been there, and it is not possible to show all the reviews. There are some reviews will be 1 or 2 words only. So if the Amazon is putting that recent reviews on the top, people may not buy the product. Okay, so that will be the purpose, to find the most the factors which are the determinants of online reviews. And we have done some literature reviews, and the reviews all directs to the rating, the size of the content, and the positive and the negative content. All those things are some of the findings. We try to shortlist these variables. We have 5 variables which will be the factors influencing the customer to click the helpfulness, the star rating, and the what we call as the word count, and then we have positive, negative, and neutral of the reviews. So we use the methodology here. We have some challenges here. We use a web scraping method we choose mobile phone. We choose some 25 brands of mobile phone to trial and test this. It's an exploratory study, and we able to collect 73,000 reviews. And out of this, we find that the helpfulness was not being clicked. So that means the number of reviews, only 12,000, we have at least at least one respondent has clicked the helpfulness. So out of this 16%, 16.9, we got it. And with this reviews, we try to download it in an Excel sheet, and we try to do the NLP algorithm to check whether classify the positive, negative, and neutral, and number of words. Star rating is already there. So you have 5 rating, 1, 2, 3, 4, that will be the classified. And based on this, we try to find out the predicting factor which will help to improve the helpfulness of the review. So descriptive of the data, and there are a lot of huge kind of differences here is there. You have a minimum to maximum. There are big ranges which we didn't control it. We are just taken everything as it is an exploratory. There are with 2 words, and there are 18,000 words also. So what we control one, what we try to do is we focus on the helpfulness vote. We didn't do any kind of control on this, and we have some 25 models which belongs to these companies, and we have different ratings. So you can have different ratings, average ratings based on the review comments. And then we have number of words, again that ranges the huge numbers. From 1 it goes to 3,500 word counts, and then we classify it based on the votes. Okay, and based on this, we try to run an exploratory regression analysis here, and be able to get that the research shows that the word count, that means the length of the review will be the most important factor in helpfulness. So I think we are coming out at least 500 words, which will make them to make sure that the review is helpfulness. So this will be one of the finding. But when it comes to the star rating, not very significantly we are able to get it. It does not matter whether the rating is positive or negative. And we are also getting that positive score is not significant. So that is one unusual thing we are able to get it. But anything negative, there is some relationship with the helpfulness. So based on this conclusion, we are trying to come out with the most important variable, which is the length of the review has an impact on helpfulness and a strong relationship with this. And the range of the words is 1,000 words and the review length is more than 1,000 words. There is possibility that they will avoid it or they not read it completely, but we still lacking on what we call as the positive, neutral and negative comments. So we try to do that, but we are not confident that the review should be positive or negative on this. And future research, we are just do a very small sample for a specific product. We were trying to work out with more data. We try to make sure that the data are also in a similar fashion. If it is a word count, we want to also control those things. And we also try to include the individuals, who is there, the characteristics or the location and all, and also the verb, emotions and other elements and images present, videos present, and all can be for the future studies. I think, thank you very much for giving me an opportunity to share our ideas. We are not more into the technical part. We are more into whether how can we make text mining useful for highlighting the most important reviews so that it helps the target audience to make decisions more faster. Thank you very much.
Session panel members, over to you. Any questions? Prabhavati ma'am. Saraswati ma'am.
Yes, sir.
Yes, ma'am. Yeah. Any questions?
Sir, actually, your work is just to find out whether the review is a proper review or not, or like
no, there is something called as a button called as helpfulness of the review. Okay.
Okay.
And what Amazon does it, the helpfulness of the review will be highlighted in the top.
Okay.
The helpful reviews will be highlighted in the top. So that is the main thing. So there is a background on, there are thousands of reviews coming. So we have to make it, because if there is no helpfulness, it won't come up top. So we have to identify that this content, the content of the review, as well as the size of the review, the person who's reviewing and all is good enough so that it will be useful for the decision makers. So it has to come in the top. So how do you make that to come in the top is we are using the text mining here.
Oh, okay.
So yeah, thousands people have given a review. Which review will be useful to the target audience? So out of the 1,000, I have to choose 10 and push it in the top. So how do you do that? That's the whole idea about it.
Okay, so the efficiency of that will depend on the algorithm that you are using, isn't it?
Yes.
Actually,
Yes, yes, ma'am.
Okay,
but we are not very strong in the algorithm part. We have used an algorithm which others are using. So we are not from computer science background.
Okay,
so we have tried it, but we are not really convinced that we can able to, the only one factor we able to get convinced is the length of the review. Other than that, we could not get that the content of the review. Based on the content, we can classify it. For example, we can classify saying that the image quality is good or image quality is not good in the phone, or the size or the speed, whatever comment they are making, we can classify. But we could not reach a position where this content is very important for the target audience and we can put it in the top. So we are working on it. We still have not get that model framework.
So it comes like ranking. Okay, sir.
Yes,
okay.
Ranking of the what we call as the futures, which has been commented in the review.
Okay.
And the second level is if that comment is good enough for the decision makers to take a decision.
Okay, fine.
Yes. Thank you.
So then, sir, next paper.
Yes, ma'am. Yeah. Thank you, sir.
Thank you.
Yeah. Next, I call upon the authors of the paper with ID 56, real-time captioning and notes making of online classes. The authors are Vasantaraman A, Sanjay Thiruvengadam V, Santosh J, and Tenmuri Durairaj.
Good morning, everyone. I'm Tenmuri on behalf of all the authors, and I'm going to present this work. Shall I share the screen,
Sure,
sir?
ma'am. Please go ahead, ma'am.
Are you able to see?
Yes, ma'am. Yeah, you can place it in full screen mode and start.
Is it okay,
Yeah.
sir?
Yes,
Yeah.
ma'am. Fine, ma'am.
Okay. Yeah, what we have done is real-time captioning and notes making for online classes, and our co-authors are undergraduate students, and their guide for their final year project, and this is that work. And what is the motivation behind this work is actually this pandemic moved all the activities online actually, and the people, especially students who find hard of hearing, will face difficulty in listening to the class and continuing their education. So this I'm sorry, I have shared the wrong presentation. One second.
No issues, ma'am.
Which lags actually.
Okay.
One second, sir. Sorry.
No issues, ma'am. Stop sharing it and.
Oh, getting tense. One second, sir.
Yes,
Actually,
it's fine, ma'am.
I wrongly deleted a content. Okay, so this
okay.
is what, especially the students find difficulty in listening to the online classes continuously. So this real-time captions will solve this kind of problem and support them in attending their class. Additionally, if we provide some kind of summaries to the students that help them to refer before coming to the next class, or even the summaries will would help them in during their exams too. So that is the motivation behind this real-time captioning and doing summarization. This is our problem statement to build an online application module which is capable of performing the two functions, especially in the lecture scenario. So one is speech to text, the other is text summarization. And what we did in this entire research is we developed a standalone web application using Flask, and we hosted in the local host for capturing the online videos and making the summary and presenting to the students in real time. Actually, what are the similar works that happen means via Scribe by IBM, they have developed a speech to text converter, and which captures
Ma'am, sorry to interrupt. Yeah,
yes, ma'am.
It is in the LaTeX
okay.
mode is there.
Sorry.
Can we see the presentation? Yeah.
Oh, maybe I could have.
Font size is very small. I'm not able to.
No, ma'am. No, actually, this is the presentation I'm showing to you all.
Yeah.
Is it visible, ma'am? The
Yeah, it's
presentation?
clear, ma'am.
visible.
Yeah.
Okay, sorry, ma'am. Sorry.
Right.
Okay. So our
No, this is
in
over.
This is fine, ma'am.
So,
You
fine,
can go
fine.
on to the
Yes,
Go to
actually,
the-
what is the idea behind this project or this work is IBM developed a via scribe and which converts the speech into text in real time, and that is another similar work is done here. So what this especially they have captured the online news and converted that into transcriptions. So yeah, one more work done by this Microsoft, but which is not doing this transcription. Instead, whatever the transcription available, who they try to identify the speakers from that. But we took the idea from this first and third work, and we like to extend that work along with summarizing the transcriptions. Like we capture the speech in a real time and try to convert that into transcription, and we will make the summary out of it. So that is I'll directly get into this is our output, real-time captions and summarizing notes, and this is our architecture basically. So we for showing as a system or as an application, we capture audio from microphone, like we treat that as a online video or online lecture, and we convert that using Google Speech to Text API, and this will convert the audio into a text form, and we add the transcript, and then this transcript will be pre-processed, and we employed a bot model, which is a pre-trained model for summarization, and we fine-tuned with our data set collected, and finally the summaries will be generated and given to the students or the user. And what is this BART model is all about? BART is the extension of BERT model, and actually BERT model is a bidirectional encoder, which employs only encoders there. But this BART model additionally uses the autoregressive decoder to make it. Actually, what is the concept behind BERT is few tokens are masked, and the model tries to learn the weights so that those masked tokens are getting back. Okay, so the same concept is being used in this bot too, but additionally, that is, if we take this particular example, there is a gap B, C, D, E, in which I can say that the C, D are the masked tokens as in BERT model, but additionally we are incorporating some noise, that not B, actually the bot model is incorporating some noise over here, so that my model will try to get the correct sequence A, B, C, D, E later. So what is the weight used to learn this particular sequence out of this erroneous and masked tokens? That weight will be taken as the final weight, and which will finally a decoder is used to generate the summary. That is the idea. And what are the different ways of generating noise for this is token masking. So if you see here, there are two sequences, ABC and DE. In ABC, we are masking this B, and in DE, we are masking D. And this is the permutation. Actually, ABCDE was there, and we are swapping them. This is we do the permutation. And another thing is we do the rotation, like we just push forward. The sequence is altered here. And another one is a token deletion. Few tokens are totally deleted. But by means of all these noise adding, my BART should get me the correct sequence A, B, C, and D, E. So accordingly, the model will fine tune itself to generate this kind of summary sequence. That is the idea of BART. And what is the contribution we made it here is, since we don't have much label data for doing this kind of online summary, there are data set for summarization, but what we need is for the online classes we need it, and there is lack of there is no label data set, so for which we have employed the semi-supervised learning. So we manually not manually, we did annotation for few data using the pre-trained model of BERT, and then we try to we just manually correct that, and we we fine tune our model with more and more iteration, that is more and more instances in incremental learning. Okay, so this is the overall view. So initially for some instance we apply the bar and we get the summary, and that summary is manually corrected. This is manual correction, and we give this corrected summary to the bar for fine tuning it. So we do this in terms of batches, and finally that is the corrected annotated data set will be added to our corpus, and that will be later used for training the model for summarization. So for in implementation aspect, if you see, we have collected some transcript for the purpose of training. We have collected transcripts from the YouTube lectures. We have considered 82 videos and we scrapped them using YouTube data APIs, and we focused on for the online classes, right? So we focus on 3 playlists, DAA, software testing and programming in C subjects, and we converted the transcripts using Google's speech to text API, and we pass this transcripts to BART model, which is available in Hugging Face, and which is the model trained on 16 GB data set corpus. And initially sorry, I finished. So the summary is okay. The summary is given by BART model will be collected, and we did the manual supervision, and finally we done this in batches using incremental learning to get more summaries. So this is our implementation. So when we start to deploy as an application, we start recording an audio or the lecture, and it transcripts like this, and after finishing the entire lecture we get a sequence of transcripts like this, and when we apply to the BART model, it generates summary like this. And how did we evaluate this is using the score of summarization, which is Rogue 1, Rogue 2 and Rogue L scores, and that is during first iteration we got this scores like this 47 for 30 and 48. Due to our incremental learning during our second iteration it was 0.49, and during third iteration it was here some dip was there, but after that it was increased to 50, 55, and there is dip again in the iteration 6, and finally if we keep on continuing this in a semi-supervised way, one point it will converge, and that we have to take it as a model, and so thereby we enforce the incremental learning in this, and these are the rogue scores we obtained for our data set finally. And to compare our work with the other summarizers, so we that is Rogue 1 score, all these Rogue score we have compared. Our BART model provides us 0.48 okay for the data, and there are few more summarization modules we have, seek to seek and text rank. Actually we when we took it this after few iterations we got more than this 52. This is for the initial iteration, basically for 48 initial iteration, and later if we keep on trying this we'll be getting 54, which is higher than our text rank module. So thereby we have shown that BART model performs little bit better when compared to all other summarization models. And this is, yes ma'am.
Ma'am, which score is a better score, ma'am?
Actually among these three
Rogue
you are
L
telling,
or,
ma'am?
yeah,
Rogue L only, ma'am. Rogue L only is the better score.
I think in the abstract you mentioned Rogue 1, Rogue 2 as well as Rogue 1 and Rogue 1 again.
No,
okay.
That is I think lower case it is. This
so
is
L.
some kind of L only it is.
What is
you
metric,
can see the difference.
Okay, what is the metric it is actually, what is
rogue
the meaning
metric
of this rogue?
Yes ma'am. How
what
many actually we try to generate the summary, ma'am, and there is a reference summary to compare what summary I'm extracting is correct with respect to the reference summary. In that, how many words are overlapping in the sense how many words I'm getting it correctly you from the reference summary, the number of words I received divided by the total words you have in the reference summary. What is Rogue 1, Rogue 2 is we consider the unigrams word by word, how many single words are extracted correctly. Rogue 2 is how many bigrams are extracted correctly. This one is some long sequence, how many long sequence it is getting correctly.
So it's better that
yes ma'am. Yes ma'am.
okay, your experimental results with some metrics are shown. But I would like to see somewhere you showed for one lecture, one summary result you were showing. Can you show that slide?
Yes, ma'am.
But that was very small and I could not read. Can you read it?
Actually,
I would like to
yes,
hear
ma'am.
what is the summary of that 1 hour lecture.
Yes, ma'am. It is not 1 hour. Actually, whatever the para is given, if I
For
read
one
this,
para, you could generate one summary.
one summary, one
But
para,
the
or
objective
that
is
depends.
for 1 hour lecture, you want to give some summary. That's what
Yes,
you
ma'am. Yes, ma'am.
started, right?
Actually, will the any summarization module will not take entire transcription as a whole, because there will be some limitations in reading the number of sequences. So there, what we will do, will divide the entire transcriptions into small chunks like paragraphs, and for the each chunk we try to generate the summary.
Ma'am, you are using bar to generate summary, correct?
Yes, ma'am. Yes,
You are
ma'am.
using
For
bar to
other
generate
paragraph,
the
you will
summary.
be generating.
Yes, ma'am.
Okay, one paragraph. What is the summary? Can you read?
Actually,
it?
for
I'm not able to
yes,
read.
ma'am. Yes, ma'am. I'll read it. Actually, the
small.
content is now. Let us look at a different platform. So suppose we have
Different problem.
photocopy campus Xerox inside university campus, something like that. And what is this? Now let us look at different platform and all is no use for the lecture, right? So those things will be removed. This is what our manual correction is doing. But my summary, actually I don't have the output of what is the exact summary retrieved by the BERT model, and this is after doing the correction, you are getting this. Maybe in the paper I will include that what is the exact
After doing
summary.
manual correction, ma'am. After doing manual correction.
Yes, ma'am. Initially we do the manual correction. Finally, for the last iteration, the model learns even that is, these are the unnecessary unwanted statements, like now let us look at the different platforms, such things and all. It identifies after some time, after some iteration, it identifies these are the unwanted sequences. It will ignore that and it gets only the abstractive content.
From the transcript itself, you will be doing data processing, right? Then you are actually bringing bot to generate a summary, right?
Here from this we are not doing so much of data processing, ma'am. We don't know what are the
actually you must do it, right? Usually you will tell no, you have to do pre-process and then you have to bring the summary, right?
Yeah, we'll do that, ma'am. Actually the so and some unwanted sequence, it will be there. We don't know the like these are all required or not to train our model. We give all chunks, noises, everything to our model, so we have to train our model to remove all these chunks.
But Tenmuri, my question is for even at least one paragraph, what is the output summary you have got from your model?
This is the summary, ma'am. Actually, this is the transcript. I'll read out, ma'am. So suppose we have a photocopy shop campus, Xerox inside the university campus. The deadline of projects approaching and a bunch of students on the project copy doesn't. So they all go and submit their something. It's a full paragraph. Finally, what is the summary it is giving? Suppose we have a photocopy shop campus Xerox inside the university campus. The deadline, only the core things are being displayed, ma'am. The statements like so let's look at all of them. So all those things are being removed, ma'am.
No, is it really the summary of this paragraph? Is it bringing in all the crux or the important focus of the paragraph?
Yes, ma'am. Like it is about, it is not related to actually for a testing purpose. Just we have read some text which is not related to our C programming, data analysis, all those things. This is for the testing purpose.
I don't see. I don't see. It's the summary is so relevant to the given paragraph. Maybe if you take a meaningful paragraph, even this paragraph, it's not like a lecture. So you have to understand the characteristics of a lecture rather than a conversation. Or the textbook kind of paragraph is, we are not going to deliver in the class like that.
Yes, ma'am. Yes, ma'am.
So we have to train with the classroom lectures, and classroom lecture is 1 hour, as you say, chunks of five
Yes, ma'am.
minutes
Yes, ma'am.
talk can be summarized. That I agree.
Yes,
But
ma'am. Yes, ma'am.
whatever summary you got is not very much near to the content of the paragraph. Please
Yes, ma'am.
take care.
Yes, ma'am. Maybe we'll take a different examples which can show the feel of summarization. We can include in the paper, ma'am. Maybe I failed to include that in this screenshot.
Okay,
Yes, ma'am.
thank you.
Yes, ma'am. That's it, ma'am.
Okay. Thank you.
Thank you.
Then
Yes, ma'am.
we'll
Thank
go
you,
to the
ma'am.
next paper.
Panel members, shall we go to the next paper, ma'am?
Yes, yes, yes.
Yes, ma'am.
I'll stop share.
Sure, ma'am. Please. Thank you, ma'am. Yeah. Next, I call upon the authors of the paper with ID titled "Disease Identification in Tomato Leaf Using Pre-trained ResNet and Deformable Inception." The authors are Arnav Ahuja, Aditya Tulsian, and J. Jennifer Ranjani.
Yes, good morning, sir. May I share my screen?
Please carry on, sir.
What is the paper ID?
Ma'am, it's 59.
Okay, thank you.
59. Yeah.
Can you see my screen?
Yes, sir.
Yes. Okay. I'll you continue.
Sure. So, hi everyone. I am Aditya. So the author of this paper is the title is "Disease Identification is Tomato Leaf Using Pre-trained ResNet and Deformable Inception." It is written by Arnav Ahuja, undergraduate at Department of Computer Science, Information System, and Department of Mathematics, BITS Pilani. Myself, Aditya Tulsian, undergraduate, Department of Computer Science and Information System, and Department of Mathematics, BITS Pilani, and Dr. Jennifer Rajnani, verified Unistate. Next slide, Arnav. Yeah. So this is about the paper. Why this is a reason behind why we opted for this topic and why we wanted to contribute on the field of agriculture.
1 minute.
Yeah.
You did an internship from third author?
No, ma'am. Actually, she was earlier the professor at BITS Pilani, assistant professor. So we worked with her till then. She was a professor, and later on we published her under she moved out of BITS Pilani, and then she's working under a firm in United States.
Okay.
Yeah. So this is the reason behind.
Can we go to proposed system, ma'am? Can we go to proposed system?
Yes, ma'am.
It's all about detecting
problem
disease.
statement we understood. Yeah, this architecture previous slide.
Yeah.
Okay, cool. So yeah, so this is the architecture. What we use is ResNet pre-trained ResNet 50 layer and Inception. So these were the two building blocks of our model. So we have ResNet 50, and what we did is we removed the last few layers of the architecture and integrated it with the Inception net, 4 layers of Inception net, and further got a final conclusive result out of the two. So we had
Arnav, sorry for interruption. We would like to understand if at all you are saying that you have combined the pre-trained models ResNet and Inception layer. You should tell why you are removing 4 layers of ResNet, why you are bringing it, what is the significance of it, and how you expected the accuracy will be more. So we have already studied your paper, and you showed some 4% for plant village data set, I guess.
Yes,
and so we would like to know how you got this concept of combining, and what is the exact understanding behind this to improve the accuracy. Only that.
Very well, ma'am. Very well. So I'll just go back to this slide first. This is the main reason why we took this. So Aditya, do you want to take this, or can I?
Yeah, you can go further now. You can.
All right. So, ma'am, like we know, the two architectures which we have used are ResNet and Inception net. So the first architecture, ResNet, we know that ResNet is itself like a great architecture, and it is known for its skip connections, which actually solves one problem, which is the vanishing and exploding radiance problem. And the Inception net architecture, it is also like a very prominent architecture. Why? Because it has unique 1+1 convolutions, and it increases the number of filters without increasing the number of parameters. So these are the two major key points of these architectures. So when we were working, we thought, why not can we take the MSP, the major selling point of these two architectures, and create it and combine it to form one architecture. That was the major motivation behind this. So that is why, first of all, we came up with this idea. Now, why did we use InceptionNet at layer 3 and layer 4? Why didn't we use it at earlier layers? So for that, we need to first understand that in the initial layers, mostly everything is just, you can say, basically, it's just the architecture only learns the simple features like some lines or some basic stuff. In the later part of the architecture, or the deeper part of the architecture, that's where the real magic happens, and that's where the real, you could say, the real, different kinds of shapes and different kinds of, suppose in this case, disease, specifications are learned. Now, the important thing is that if we include different multiple filters, then the logic which we used was that if we include different filters, then we can maybe increase the scope of the the detection, as well as incorporate multiple filters without increasing the number of parameters. That's why we included inception module in the later layers. One more thing, if you note, is that if in this last layer we have also retained one RESTnet, one RESTnet bottleneck layer. Why is that? Because actually in the last layers we initially included the InceptionNet only, but we observed that the accuracy was not taking a, it was going down only. And why we thought this was happening was because one plus one convolutions actually also sometimes decrease the scope of the you could say the scope of the feature map. So basically, if we decrease the scope and at the later point of the module, then basically what could happen is that the accuracy could decrease. That's why we thought the accuracy is decreasing, and ultimately we had to go back to the RESTnet, and that's where we realized that the accuracy is going fine over here, right?
So your combination should have increased, must have increased the or decreased the training time, correct? Because you are bringing the 1x1 filters in order to reduce the parameters to be trained, correct?
That is also true, ma'am. But we actually also, in the later part of the project, we also incorporated deformable convolutions. Why? Because we wanted like a majority of the, we didn't want exactly the same feature maps all the time. That is why we also use the inception module, and inside that we also use, you could say, deformable convolutions. But we couldn't actually use it in the entire model because of lack of resources. I mean, because of resource constraints. But we use it in the last layers. May I go ahead?
Yeah, Arnav, just one thing. Can you go back once?
All right.
So just adding to what Arnav said, so also the reason rationale behind choosing InceptionNet and RESTnet was key, like InceptionNet gives us the depth of the architecture. So since our data set, especially the plant doc data set, which was taking in a real-time environment, and the size of the image could highly vary. So we want to have a trade-off between how much depth should we choose and how much width should be the width of the architecture should be. So that's why we preferred RESTnet and InceptionNet, which is the right combination, that RESTnet gives us the depth so that a actual image, real-time image, can be properly classified, while InceptionNet gives us the variation in the filters, so that we can choose on, we can add the breadth to we can make it more wider and give the breadth and options to the filters to identify the image and classify the image in a better manner. So like this was also an idea behind choosing RESTnet and InceptionNet only, and not any other architecture. Yeah, we can move on.
So there are two major data sets which we have used. One is the plant village and one is the plant dog data set. So the difference between these two data sets is that the plant village data set, it is like an ideal data set, which means that it has large number of images, right? And it has images in ideal conditions. For example, if you see on the right, these images are in ideal conditions, which means there is no noise in the background. They are taken in the laboratory conditions. There are perfect lighting conditions. So, and any model, when any CNN model, a convolutional model, can easily detect the diseases in these and classify them. But the major challenge lies in the plant dog data set, which is not an ideal data set. It has blurry images, it has images of different sizes, and it has very less images also for the tomato, which are around 800 only. So huge models will ultimately overfit to them only. So these two data sets which we had and we wanted to work with them. So now the first goal was to improve the accuracy which was already there in the ideal dataset, which is the plant village dataset, right? So the initial accuracy which we had in the earlier reported accuracies was 97.5, and with our model, which was inception ResNet, we increased it to 98.16, which was around 1% increase. So we were happy with it. But now for the plant dog dataset, the already existing accuracies were very low, 30%, 29%, 25%. And that was because of the challenges which I've already described. So we wanted to increase these accuracies, and that's where the major work comes in. So what we did was to get a higher accuracy on the plant doc images, what we did was we created masks on the plant village dataset. And so this is images of the plant village dataset with just the mask on the leaves, right? And now we superimpose these leaves on the plant dog dataset modules. Why did we do this? Because the images of the plant village when you superimpose them, now they are mimicking the plant dog dataset in one fashion, because they are now these are now leaves with you could say green backgrounds and noise in the background. So there we could basically mimic the plant dog dataset. That was the major you could say the intuition behind doing this step. And the observations also supported this. So initially, if we observe that so this table actually shows just the ResNet, only the ResNet architecture, not the architecture which we have created. So basically, if we just look at the ResNet architecture, we'll see that for the plant dog dataset, there are very low accuracies, 26, 29, 27%. And for the plant village dataset, the highest accuracy which we were getting was 97.5, as I've described earlier. But the thing is, when we use the new dataset, which we created through data augmentation, we observed that the accuracy for the new dataset, we trained it on the new dataset and it went up to 99%. And then we tested it on the plant dog dataset because it was mimicking the plant dog dataset conditions. And we observed that the accuracy was about 65%. So this was a proof of concept of our of the new dataset which we created. It showed us that the accuracy of the ResNet itself was increasing without even using the model which we have created. Now coming to our model, we already saw that the plant village accuracy was increasing to 98%, which I've already described. But also without any modifications, we were getting 58% accuracy, 59% accuracy without any modifications in the new dataset. And ultimately, when we used the new dataset, we got a 66% accuracy, which was greater than the ResNet. So this showed us that our dataset which we have created was first of all was working. It was a successful idea. It was a successful hypothesis. And also the architecture which we have proposed also increases the accuracy even further. So these were the basic observations. Also, we compared this with some benchmark architectures like AlexNet, VGG, and we saw that they were getting lower accuracies like 73, 20, 30%, 46% in the new dataset. And that's where we thought that our dataset and our architecture was working in a great manner. So I think we look forward to this being used in multiple different areas. Our architecture can also be used in different classification problems.
Arnav, can you go to the mask portion of the slide?
Yes, ma'am. Are you talking about this slide, ma'am?
Yeah.
Yes.
So you are basically transforming the data from plant dataset, right? So when you apply the mask of that size to for example, bacterial spot or leaf spot, so the damaged portions might be removed from the plant doc dataset, isn't it?
No, ma'am. Actually, so the thing is, so if you look at this leaf spot picture,
second picture, go to second. Yes, the upper row, first row, second picture. Yeah, okay. This is the mask. You say that this is a mask.
Yes, ma'am.
This you are going to apply it over plant doc dataset, leaf spot.
Yes, ma'am. Yes, ma'am.
You are going to superimpose this over this.
Yes, ma'am.
when you superimpose this over this, then the size of the second leaf will be retrieved from the leaf spot. This is what is my understanding. Is this correct or not?
Can you repeat, ma'am? The size of the leaf you're saying?
Superimposing means leaf spot. If you superimpose the second image of the first row over the leaf spot, what will be the result?
Oh, okay. So yes, ma'am. The superimposition was because just taking this leaf and superimposing on the
Leaf
same
spot.
disease and same. Yes, ma'am. That is true.
Leaf spot. You just superimpose that over the leaf spot. What will happen? Only that portion will be extracted. Correct?
That is true, ma'am. That is
true. That is true. So you are taking some size of the mask and you apply it over plant doc data set with some other size, and you might be missing some disease from that way, right? If you just superimpose without knowing what is the structure of the leaf in the plant doc and structure of the mask that you are having, you're retrieving it from the plant village data set. You are getting my point. And in that case, how do you claim with empirically only you are claiming that the plant doc new data set that you have created is actually improving the accuracy with your proposed model? Am I conveying properly? You are not actually taking
yes, ma'am.
taking into consideration the structure of the plant village data set to be superimposed over the structure of the plant doc. You are simply randomly doing it and bringing it to your hybrid model. Correct?
Yes, ma'am. I think, but
yeah, that's all I wanted to know.
So, ma'am, just to clarify here, add a point, like when we have a when a leaf is infected with a particular disease, no? So you don't see a particular spot only infected. So we don't say it is infected if we have a particular spot. If you'll see the image of the second row, second column, so there is a huge portion which is infected. So when we mask an image now, we don't see it is highly unlikely that this complete portion will be removed and only the part which is not infected will be seen. Similarly, in the second row, second column, first bacterial spot image, you can see the spots of bacteria infection multiple places in a single image.
Yes, you can retrieve the infected, but if you could consider the structure, will it improve the accuracy still when you're forming a new data set?
So yeah, it won't, it might not that significantly. There might be certain cases where it might not be able to detect, but in our cases, what we found was that majority of the diseases where we were able to help, it might be because of tomato leaves. Specifically, we focus on tomato leaves. It can be the reason that's why we received such a high accuracy. But in general, when we masked, we tried to consider that the broader perspective was taken into picture, but not more than one leaves we take into account, because that would further, it was basically kind of precise and recall. It was basically false true and false negative. So kind of situation was there. So we tried to take try to keep it in a single leaf only, though the area under consideration can be reduced. Yeah.
Okay, thank you.
Right. So I think we are done from our side. There are any more questions, ma'am? Then we are ready to answer them.
Yeah. Thank you.
All right.
Yeah.
Thank you.
Thank you,
so much.
authors.
Thank you.
Yeah, thank you, authors. Next, I call upon the authors of the paper with ID 61, title Allowance of Driving Based on Drowsiness Detection Using Audio and Video Processing. The authors are Satish S, Maheshwaran S, Mohana Venkatesan P, Muhammad Azaruddin M, Saumita K, and Subhash S. Over to you, authors. Please share your screen and start the presentation.
Yes. Sir, is the screen is visible, sir?
Yes. Can you make it a full screen and start?
Yes, sir. Yes, sir. Sir, it's now okay, sir?
Yeah, fine. Carry on.
So, good morning to all. Our project is allowance of driving based on reduction using audio and video processing. And myself, Mohan Impression. My project mate is Mohammed Azaruddin, and we are guided by Satish sir, assistant professor in our department. Our main objective is to develop a system that verifies the drowsiness detection of a driver before he starts to drive. There are two. Our main motto is to approving the keys of the public transport to start to driving. So nowadays, safety and protection is are more important in our life. So mostly the accidents are happening in the night times due to the drowsiness of the driver. Next.
Problem statement. Even though the presence of drowsiness detection system in the vehicles, the accidents have happened because this process starts after the beginning of driving. Literature review. These are the papers we have referred for.
Proposed system. Can you go to proposed system?
Yes, ma'am. Yes, ma'am.
Existing work. Go to existing work and show the flow.
Okay, ma'am.
No. That diagram.
Okay.
Diagram.
This is the process of starting after the driving starts. When the drowsiness is detected, if yes, then the alarm sounds and stops. If not detected, it will go. It will run again.
Okay. Go to the proposed architecture.
Yes.
So now let us see the proposed architecture. In this, first the driver, in the existing system, the driver will the drowsiness will be detected only after the driver starts. But in our proposed architecture, the driver will be drowsiness of the driver will be detected before the driver starts to drive. In this, we have two levels of verification. First level verification process is that audio listening process and the capture process. We divided into two parts of the first level verification process. For literate people of drivers, they are using capture. They are using for capture process. For illiterate people, they are using audio listening process.
Got it. Go to detection of facial expressions.
In second level verification, so
no. The architecture diagram. Go back. Facial detection. Detection of facial expression. How are you going to detect the drowsiness from the face?
So,
Next slide. Next slide. This one.
Ma'am, here we have capturing some seconds of video and processing the video, convert the video into frames, ma'am, and it'll give the each frame as input image to the to our system, and then we are using our cascade classifier for that. Here there are 4 steps are there: hard features extraction and integral image processing and ADA boosting technique and cascading process are done. First, R feature extraction. There are 4 features are there. 3 features are there: X features, line features, and 4 rectangle features will be detected. And then in integral image processing, it reduces the number of features detection without taking the irrelevant features. And ADA boosting technique. In ADA boosting technique, we have limited the number of features that we extracted in that. So after that, all the after the output of the previous stage, we'll get the input for the cascading process, in which at each stage there will be some weak classifiers, and we adding all the weak classifiers into strong classifiers, and we get the output.
What is the meaning of object is detected here? You are detecting drowsiness alone, no? Why you are saying object is detected?
That is face detection. Face detection and eye.
You are not detecting face, isn't it? You are detecting the expressions.
Blinks of the eyes.
I'm blinking of eyes and facial expressions, ma'am. Yarning like that.
Okay.
This result. Here. First, this is a output for literate peoples. Here we'll do the capture process first. If the capture is entered correctly, the level 1 process is completed. Or for illiterate peoples, your audio will be played with the capture in our mother tongue. So he will be replayed in replay the audio, which will be played correctly, and both the audio will be matched correctly. Then we are allowed to the next level verification process.
Compared to existing drowsiness work, how your work is good?
We are detect the drowsiness before the driver starts now. In all the existing work,
this process is started after the driving.
Driver starts to drive.
Not necessarily, right? Even when he is driving in middle, also he may get drowsiness, right? He may get sleepy.
Yes, ma'am. Already the existing system was there, ma'am. But it may leads to disturb also disturb the passengers also.
So the same method could be used before the driver starts, right? So why your system is needed then?
Our main motive is to detect the driviness and key approving system.
Our main motive is key approving system for transport, ma'am. If the system allows the driver to drive, then he will drive.
Approve the key to drive.
He will approve the key.
Ma'am, I'm done, ma'am.
Yeah. Any more results?
Ma'am, if the open score is 0, then the level 2 checking is also completed and the key will be approved. That's it.
That's all, ma'am.
That key approval, in my view, it's just a decision whether to give the same system could be used. What is your paper ID?
6-1.
6-1. There is a spelling mistake in your figure 5, illiterate. Okay. In figure 15, accuracy of the proposed system, what is P and what is E? It's not at all given. But you mentioned.
It is given. It is proposed system and
existing system, but we are not able to understand from the figure like that. Since you are telling, we are able to understand, but there is a spelling mistake also you should see.
Okay,
but we also mentioned in the paper, so that.
Okay.
Okay. Thank you.
Please ensure that all the figures and references are cited in the paper.
Okay.
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 Because some of the references and one figure is not cited. Please take care.
Okay.
Okay. Thank you.
Thank you, ma'am.
Thank you, authors. We can stop sharing the slide. Next, I call upon the authors of the paper with paper ID 63, titled Enhanced Residual Connections Method for Low Resolution Images in Rice Plant Disease Classification. The authors are Satya K and Rajalakshmi M. Over to you, authors. You can share your screen and start the presentation.
Good morning, sir. So shall I share the screen now?
Yes, ma'am.
Yes.
Can you make it full screen and start?
Yes, sir. Yes, sir. Just a minute. Sir, is it okay, sir, now?
Yeah, it's fine.
Yes, sir. Shall I proceed, sir?
Yeah, please.
Yeah. Yes, good morning to all. Today I'm going to present my paper entitled Enhanced Residual Connection Method for Low Resolution Images in Rice Plant Disease Classification. Myself, Satya. So why this is the outline of my presentation. Coming back to the introduction here, why we go for single image super resolution, because initially the images which we are obtained from the real-time cases or some few cases images, sometimes it may be in a high resolution, or sometimes it may in low resolution. This what is an objective of single image super resolution is aims to reconstruct or restore the image from the either from these either from this high resolution or super resolution from the low resoluted images. This is the one. How it can be done with the help. Why we go for this kind of problem? First one is, if all the images retrieved from the real-time cases or from the existing one or in super resolution form, why it is needed is because of the performance. If you go for in any computer vision problem, the performance the performance speaks more when we go for high resolution data. The thing is, nowadays the resolution images are available in few cases, but it is more expensive. In some real-time cases, it is not readily available. In those cases, we need to reconstruct the image from the that is input images we have to reconstruct it. Then we go for applying some super resolution methods. After that, we fetching some high resolution data. So it is possible all the time the high resolution images are not possible because due to the limitations of sensors and some in the optical industries. So according to the here, these super resolution techniques can be based on the input data. We can classify this problem into two types. One is single image super resolution, and second one is multiple image super resolution. Where it is applicable, then next question is where it is applicable. For example, in real-time cases, these super resolution problems are applicable in medical images, security and surveillance, and video enhancement, and some other kind of video segmentation. But if you go for these kind of problem, but agriculture plays a vital role. So and here for this paper, I taken a real-time application as agriculture domain, especially the rice disease classification.
Ma'am,
So
please
coming
go
this-
to proposed
Yes,
architecture, ma'am.
Okay, ma'am. Okay. So this is my problem definition. So I started with this problem definition.
Fully understand your problem definition. Please go
Okay,
to architecture.
Okay, ma'am.
The idea is to improve the low resolution image, right?
Yes, ma'am.
And
yes, ma'am. Idea is to improve the low resolution images, ma'am.
Right, and
the
you are
help-
going to use some method and you the existing method, and you're going to enhance a little bit to see how much it is improving your image. This is the understanding. Is this
Yeah,
correct?
ma'am. Yeah, ma'am. Yeah, how much it is? How much the image quality is varied with respect to
Your
the different
enhancement.
techniques,
Yeah,
enhanced
different.
methods.
You
Yes,
might
ma'am.
have taken some image super resolution method. What is that?
Ma'am, here initially I started with two types of super resolution method. One is VSDR, another one is residual network. So combination of two, which comes under the enhanced residual connection for the super resolution. That is my proposed model. It is a combination of both VSDR model as well as residual connection.
Understood. 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 The data set.
Ma'am, yes, ma'am. Ma'am, this is the basic block, how the original resonate is there.
Ma'am,
And
please
how the
go to the
proposed one.
previous slide. Please go to previous slide.
Yes,
And in
ma'am.
that div 2K data set, what is it about?
Ma'am, div 2K data set, it is a diverse 2K data set. It holds of, ma'am, I will show the images, sample images.
Cat images.
Yes, ma'am. Ma'am, all together, the real-time scenarios, all these kind of images are in the div 2K image data set, ma'am. It is a challenge, super resolution problem challenge. This is a benchmark data set, set 14.
All
set
kinds
D.
of images. All kinds
Yes,
of
ma'am.
images, correct?
Yes, ma'am. It kind of
Div
all
2K.
kind of images.
All
The
kinds of
urban,
images.
yes, ma'am. Urban 100, it is only pointing out the urban cities, city images, whereas B100 it holds of all, ma'am. Similarly, it is set 14 and set 15. The sample images are here, ma'am.
Those are all face images.
Yes, ma'am. Yes, ma'am.
Okay, you are actually considering different types of images, correct?
Different
Here,
types of images.
plant images,
And,
rapid it is, RPD it is.
RPD is rice plant disease image
Rice plant
data set,
disease.
ma'am. Here we include 6 classes of rice plant diseases, and also healthy images also included, ma'am. It is a real-time data set, ma'am.
You would like to improve the resolution of rice plant images actually, but why you are considering all these kinds of images now?
Ma'am, first, no, ma'am. The first I started with a super resolution model, ma'am. So initially I started with working on benchmark data set. Then once I obtained the accuracy is better comparative to other models, so applied the same on the real-time data set and identify how it is working, ma'am.
For rice, okay.
Rice plant diseases.
Got it.
And also for rice plant diseases, I ended with disease classification. If suppose in real time there is a possibility of obtaining during the image acquisition, there is a possibility of obtaining low resolution image in case of if we fix drone image, if we fix some drone kind of images, UV vehicle kind of images, sometimes there is a possibility of low resolution images. And also if we fix some camera, there is a possibility of
got it.
Yes,
Proposed architecture. by
Yes, ma'am.
this means of if you obtain images, it will be in low resolution. We are able to understand
Low
that.
resolution.
Yeah,
And how
got
the
it.
accuracy is varied, low resolution and also super resolution, ma'am. That is what my end of my presentation, ma'am.
Yeah, this architecture you explain.
Yes, ma'am. Ma'am, initially I started with two different types of data set. One is DKV2 and training data set. This is RPDID. It is for rice plant disease data set. Initially, it holds either it is of high resolution or super, that is high resolution images, or some kind of low resolution images. First, initially it is applied to downsampling block. Downsampling, we applied a bicubic interpretation technique, basic interpretation technique to resizing the initial images to convert into low resolution images. Then apply to the residual block. Residual block holds of CNN layers followed by residual block, and then next one is upsampling block. Then after fetching all this that is ISR images, it stands for super resolution images. Then further I go for that is disease classification. This is a proposed method. It holds of two types of stages. First one is it is of super resolution block, and second block is disease classification block. So in residual block, initially the SR ResNet mimics the same architecture of ResNet, but the thing is, it is we removed from the base ResNet architecture and SR ResNet architecture. We remove some layers based according to the problem statement which we fetch for the super resolution problem. Then we go for the next one. That is, it is ResNet super ResNet model. ResNet model is applicable for three different upscaling factor. So we used from the data set, we used three types of scaling factors. One is 2x, 3x, and 4x. So for different kind of scaling based on the different type, this is used. From the proposed model, we remove batch normalization. The role of batch normalization is used mainly for fine-grained learning procedures, and also what is the main role is it is used to aggregate the information over the set of images. So in case this is not needed for even it is for image blurry or super resolution problem. So it is not required. The normalizing the feature is in final at the end, if you are using batch normalization in this proposed block, it takes much time, and also it occupies more spaces too. And in terms of computation requirement, it also affecting the computation requirement also. So normalizing all these feature, it resulted in over enhancement. So we removed that one. We checked both adding batch normalization, what it happens, removing the batch normalization, what it happens. We finalized, we got better results when compared to removing the batch normalization in the proposed block.
So
then
your proposed methodology is coming out empirically, correct?
Yes, ma'am. Yes, ma'am.
Okay.
And this is the upsampling block, and this is a scaled super residual block, ma'am. And then the experimental setup started with different types of data set, both benchmark as well as the real world data set. And totally the model is trained on due 2K data set. It holds of 1,000 images. So we segregate a split ratio training and validation and testing part. And also we test images based on set 14 B100 and also urban 100, and the model is trained of the patches which we fetch from the high resolution images. That is high resolution images is 48 cross 48 RPG patches, and initially the images given for training is 800. So we done augmentation stage. The model is trained. Yes, ma'am. Yes, ma'am.
So if you after having improvised the resolution, you come to a conclusion that the resolution has been improved with the help of accuracy metric. Am I correct, or is there any other metric?
Yes, ma'am. One is for image quality assessment, we used PSNR value and SSIM values, this structure similarity metrics.
So
And
after you improvised the resolution, you are using this PSNR value to see that yes, the image is improved
images
the resolution.
is a resolution or not? Yes, ma'am. Yes,
And then you are going for classification, correct?
Then we will go for classification. Ma'am, I tested all the images. See here, ma'am, in the slide, yes, ma'am.
After improvised resolution, you have gone to classification method, and you sent rice plant images without resolution improvement and with resolution improvement, and you got an accuracy improvement.
Yes, ma'am. Yes, ma'am. Yes, ma'am. This is the actual result which we retrieved based on the disease classification, ma'am. All the disease rice plant diseases, and also we worked on rice pest diseases also, ma'am. But we more focusing on rice plant diseases. So the result which I'm showing here is only for rice plant images alone, ma'am.
What is the graph shows? Loss is more loss versus accuracy curve.
Yes, ma'am. Loss versus accuracy curve, ma'am.
Accuracy is
train accuracy and test accuracy, ma'am. And
where is
it is of both of loss and yes, ma'am.
What is y-axis?
Ma'am, y-axis is an yes, ma'am, loss, ma'am.
It is loss. The x-axis is iterations.
Yes, ma'am. Yes, ma'am.
Loss is persistent when the iteration improves, and
yes,
loss is getting decreased. I mean, accuracy is persistent and loss is
persistent. Losses, yes, ma'am.
Okay. Why there is disjunction in the second graph? Why there is distortion? Okay, fine.
Ma'am, it is we are using more testing on more number of data set. There is some distractions, ma'am.
Okay.
Ma'am, and finally we conclude that the ResNet 50 is giving more accuracy in terms both for that is one for a super resolution model, whereas for inspection that is for efficient net, it giving better performance for LR images, ma'am.
Ma'am, I'm done.
Yes.
Yeah, lot of feedback is already given.
Yes, ma'am.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Yeah. Thank you,
thank
authors.
You, sir. Thank you, sir. Thank you, sir.
So next I call upon the authors of the paper with ID 69 titled GPS Tracking Traffic Management System Using Priority-Based Algorithm. The authors are Manjula S, Suganti M, and Anandan P. Over to you, authors. You can share the screen, start the presentation.
Yes, sir. My screen is visible. Sir?
Yes, ma'am.
Yes, sir.
Yeah.
So, good afternoon, one and all present here. So, my paper title is GPS Tracking Traffic Management System Using Priority-Based Algorithm. So, this is relevant to that hardware project. So, myself, Manjula from Rajlakshmi Institute of Technology, presenting this paper. So nowadays the problem is number of vehicles are more, so that the traffic congestion is the major problem in urban areas. So that the objective of this paper is that real-time dynamic traffic management system. So this is purely based on the density level on each junction. So with the help of the geodensity information. So this is my objective of the paper. So under the literature survey, a lot of work is carried out. So RFID means less access range, and load cell means that implementation is very much difficult practically. So and that image processing technique, this is also the complexity of implementation is more. And then ultrasonic sensors also, the cost wise is very high and less scalability and reliability. So that I am proposing this this model. That proposed model consists of two parts. One is traffic density sensing part, Another one is decision part. Actually, this traffic density sensing part, it is available in the vehicle. So in this hardware, this module, which contains the GPS and GSM module. So the from the GPS and GSM module, we can track the coordinates. So we can acquire the coordinates of the vehicle, and it is given to the microprocessor. So in this microprocessors, already the geofenced location is already set by. For example, if one traffic signal is available means, so for 8 kilometer or 1 kilometer, so the distance will be represented by the location, geofenced location. This means location it covers means. So from the GPS module, if the vehicle is available within that geofenced location means, it's automatically count the number of vehicles count to the real-time databases. So this database is we are maintaining in the cloud. So in this database, it updates the count in which junction and which crossing it is in the vehicle. Everything it is updated in the real-time database. Another module is decision making part. This module is available in the traffic signal. So near the traffic signal. So from the real-time database through the internet, from the real-time database, so we acquire that coordinates. If it is depends on the number of vehicles, the density of the vehicle, it is given to the microprocessor. So according to that coding, the priority-based algorithm here implemented in the processor. So according to that coding, the traffic light will be changed. So this is that methodology. Here, actually, this is the flow chart. In the GPS sensing, so the coordinates is if it is in the geofenced location means update the count in the data into the database. So from the database, it checks the higher priority, which crossing is having that more number of vehicles. So according to that, it gives that access to that the particular crossing. So every time this process is continue, after 15 seconds, this process will continue. So this is the priority based algorithm. So it starts running. So we have that each crossing, we have that controller. So data to controller. So this is crossing 1. If that crossing 1, the number of vehicles is more than that crossing 2, 3, and 4 means. So if it is more means, so it access to the green signal. First amber 1, that yellow, and then green 1. So if it is not means, and then red signal. So according to that, every crossing it will be checked using this priority based algorithm. So this process will continue after 10 seconds. So every 10 seconds this will continue. So for example, crossing 2, if number of vehicles is 15 means, so the immediately the green signal will allow the vehicles to that crossing. So here we are maintaining that real-time database. So in this real-time, actually the coding has been done by using the Python code. So here the junction 1. So we have 4 crossing 1, crossing 2, crossing 3, crossing 4. So here the geofenced location. So according to that coordinates, 15 vehicles are in the crossing 1, 25 vehicles, and 12 vehicles, and 33. So crossing 4 is having that more vehicles, so that the crossing 4 the signal is green signal. And this is room data means if we have that more number of junctions, if we have taken the data, this is the first junction. So and this one this is my C1, the same thing only, C1, C2, C3, C4. So real-time database, I'm showing the results. This is the programming code with done. So the result is like that, crossing with highest priority, the crossing 4 like that. So this is the module, density sensing module. So in this we have using that processor means Arduino Uno board, and for the internet connection we use that Node MCU. So this will provide the Wi-Fi compatibility, and we have GSM and GPS module here. So from this module we get the coordinates. And it is given to the real-time database. And this is the output. This is the decision making part. So here I am using the Raspberry Pi, that processor. So the Raspberry Pi processor, according to the priority based algorithm, it changes the traffic signal light. So this is the final hardware output based on that computed value. Sorry. That's all. These are the references. Hello.
Yes, ma'am. Panel members. Kanchana ma'am, Prabhavati ma'am, or Saraswati ma'am.
Ma'am, you have shown the final output, no? In that all the three lights are glowing, ma'am. At a time, only one should glow, no?
No, ma'am. Actually, which crossing we have the green signal that's like
Oh,
only.
so each one represent different crossing. Okay.
Yes.
Okay, ma'am. Okay.
Ma'am, I would like to ask one question. What is the novelty of this work, ma'am? What is the existing traffic light controller is there and it is being automized? So how come your work is significant over the existing one?
Yes, sir. Actually, nowadays, mostly they are using one is traditional method is the constant timing, like 30 second or 45, 60 seconds, 1 minute. We couldn't, for example, if one crossing, we have that more number of vehicles, but other crossing only 2 or 3 vehicles. So on that time, because of that constant timing, so that all the vehicles will not go based on that high density. So in that, so because of the existing works is RFID, load cell, and electromechanical controllers. So these and all are using, and ultrasonic sensors. These and all using. But in this, from this existing method, one is cost problem, another one is that will not be implemented effectively. So because of that, because every vehicle has that GPS model, only we have that controller means automatically we updated the database into the cloud. The cloud will direct that traffic light means from the cloud means. So this is very effective and the cost effective solution also. So that is the
Okay. But how come you are evaluating that this is the dynamic timing that I have to place for the controller to change the signals? Because based upon, as I said, as you said, you are checking on with respect to the number of people, right? Number of vehicles that is being passed. How can you determine that? Because at a point in time, I can have 10 vehicles. How can I determine that the next part? Yeah, next part only 10 vehicles will come. How can you determine the
yes, sir. Yes,
number
sir.
of vehicles?
Actually, crossing one means we have that geofenced location. For example, I'm telling that 10 cross 10 for simple mathematically. So 10 cross 10 means that location, that diameter like that 10 cross 10 means. So within that 10 cross 10, how many vehicles? That data is updated into that real-time database. Similarly, crossing 2, the 10 cross 2. So 10 cross 10. So within that 10 cross 10, so we have that vehicles, for example, 10 vehicles are in the crossing 1 means that will be updated crossing 1. We have the 10 vehicles.
So yeah, I understand. How you, what is the API that you are using to upload it in the, you have, I think you have used Firebase, right? So you are you using any good already existing APIs to load it, the real-time data?
No, sir. This just directly implements.
Okay, ma'am. Yeah, thank you. Panel members, if you have any additional questions. Okay, ma'am. Thank you so much for.
Thank you, sir. Thank you.
Yes, ma'am. You can stop sharing it. Yeah. So next, I call upon the authors of the paper with paper ID 76, titled Literature Survey on Human Behavioral Analysis Using Deep Learning Algorithm. The author is Mrs. R. Purani. Over to you, ma'am. Please share your screen and start the presentation.
Very good afternoon, sir. I'll start my screen presentation now.
Yes, ma'am.
sir, is it visible, sir?
It is
Loading.
yet to get shared, ma'am. Yeah.
Okay, sir.
Ma'am, can you just check your internet connectivity and reshare it? Yes, ma'am. Now it is visible.
Okay, sir.
There is a background noise from your end. I think it is a fan's noise. Can you just deal over it?
Yes, sir. Sir, now is it visible, sir? I hope
Yes,
my...
ma'am. You can put on the full screen mode and start.
I've started with full screen mode, sir.
Oh, ma'am, it's not been shared. It's full screen. Maybe due to some net delay.
Ma'am, can you stop sharing it and share the full screen, ma'am?
Okay, ma'am.
Because you have shared the PPT, you can share the slideshow.
Okay, ma'am.
Ma'am, what you can do is you can put it in stop screen sharing,
Okay,
put
ma'am.
it in slideshow, and then start screen sharing the slideshow.
Ma'am, but when I'm starting up with the slideshow,
You open the presentation and press F5 so that it will go on to the slideshow mode. Then start sharing the screen.
Yes, sir. Yes, sir.
ma'am, once I come to the screen, it's getting out of the slideshow mode. I'll give the screen itself, ma'am. I'll share my entire screen so that. Is it okay now, ma'am?
Yes, ma'am.
Yes,
This
ma'am.
is fine.
Yeah.
Yes, ma'am.
Yes, ma'am. So very good afternoon to one and all present here. Today, I'm going to present over the title, Literature Review on Human Behavioral Analysis Using Deep Learning Algorithms. So the introduction part is nowadays the human behavior analysis is being like an active research area in the computer science and engineering field where we are going to analyze the behavior of the humans using various algorithms, not just deep learning algorithms, but we use various algorithms to analyze the behavior of the humans. So here I've planned on developing a human behavioral analysis model which can determine the behavior of the human, and this is going to be the survey of what I've done and what I've taken the survey from various papers. So here the input can be taken from the real-time environment to analyze the human prediction. So when we mean by real-time environment, we are going to take the input from like the video. We are going to take the input as a video. So we are going to use a web camera or sort of things to take the real-time environment to capture the real-time environment video upon which we are going to analyze the human behaviors. So here the major target which we are planning on is the deep learning algorithms, because deep learning algorithms are giving an accurate result and it is giving a more efficient output when it comes into the behavioral analysis. And here we are going to involve a lot of computational images, the spatial temporal informations about the images, and also we can use the real-time videos upon which the predictions can be made. And so here in this paper, various concepts and algorithms that are implemented in the various fields of image analysis are discussed. So the very first literature survey paper that I've taken is from the IEEE journal, which is human action recognition using deep learning methods on limited sensory data. So here the accelerometer and the gyroscopic data is used in a lesser amount to build the action recognition system. Here they have combined various deep learning algorithms. They have not implemented with one particular deep learning algorithms. They have used a combination of different deep learning algorithms and their performance were compared. So here the accuracy of the model was increased while augmenting the data. Like they have taken the actual data and they have taken the augmented data. So when they compare the accuracy of both of these, they can identify that the accuracy of the augmented data is bit higher when it comes compared with the actual data. So the more and more data we give, the more and more the input that we give, the accuracy of the model is getting increased. So here they have used the three-layer LSTM model, long short-term memory model. The accuracy was increased by 97.4%, and the overall collected data system produced the 99% of accuracy. And then the second survey which we have taken is the joint motion information extraction and human behavior recognition in video based on deep learning. So here focus on the human behavioral analysis and identification from the videos. In the previous paper, they have focused more over the images, whereas here we have focusing more on the videos. So here the deep learning convolutional neural network model, they have developed a two-channel network, and one is for the schema and one is for the feature extraction. So when we mean by schema, they have used the edge detection mechanisms to identify the schema, and the features are extracted from the joint motion. Here the network structures, they also simulated the brain visual cortex, which process the visual signals. So here the static information is processed by the spatial channel network and the dynamic information is processed by the temporal channel network. So there the spatial information and the temporal information from the videos are extracted separately, and the recognition of the double channel mode is compared with the single channel mode to identify which performs the best. And then the third survey is the multimodal analysis of personality traits on video of self-presentation and induced behavior. So here in this paper, they have used a multimodal deep architecture to evaluate the human behavior from the visual elements of video. They have taken the audio signals and the text converted speech. So for the evaluation of behavior, the audio visual data set with self presentations recording they have taken for the induced behavior, and the reliability of the various behaviors and their combinational uses assessed. So here they have used a phase normalization. Since it is like a self presentation video, they are focusing more on the facial expressions. So the phase normalization is done by marking 68 boundaries of the facial region from which the video is assessed. The frontal view of the face is obtained by performing the translation, rotation and the scaling mechanism. So they are going to mark the X and Y coordinates, and they are going to shape the normalization using the linear wrapping method. And finally, the facial boundary regions with the resolution of 224 cross 224 pixels are obtained. So upon this normalized facial images with the spatial temporal patterns, they have used the RES next model and the CNN GRU model. So here the facial appearance
Excuse
and the
me?
Yes, ma'am.
Without spending much time on the literature, can you please go to your proposed architecture?
Ma'am, the paper itself is a survey paper, ma'am. So
talk
Survey
about
paper.
no, ma'am. In that case, she can talk about the issues that she wants to bring out of all these literature.
You are explaining too much of one paper.
Existing
If it is
literature,
survey of many papers, then you have to take one feature and compare across the papers.
And then you suggest what needs to be done in order to improvise something.
ma'am, do you have a tabular kind of
issues.
structure which
Yes, ma'am,
represents
I
all
have
the
a-
papers?
Yes,
Yeah,
I
if
have,
you
sir.
have that, you can go.
Yeah, then it
This
be better.
looks
Fine.
good. You explained this. Don't get into the details of each paper.
Okay, ma'am.
Compare the papers and tell which is better or where there is a gap, something like that.
Ma'am, since this is, I've taken it as a survey, I've just studied all of the papers, ma'am. I've taken input from all of the papers, and finally I've given the conclusion and the future work of it.
Yeah, what is the future work? That's what is more interesting. What are the research issues that you found by studying all these literature?
Okay, ma'am. So when it comes into the major factor which act as an issue is the accuracy, ma'am. So when they are using an input of one particular type, and when they want to change it to some other type, or when, if say for example, if they are taking it from the images, and if they want to convert it into the same model to convert it into a video, then the accuracy getting reduced. So these are the common factors which I face in all of the papers that I've studied. So they are taking a spatial temporal information, and if they want to build the same model for some other type of data, then the accuracy was not up to the mark which they have obtained with the restricted environment or the specialized environment which they have made the paper over. So here in the in this last paper explaining the unique behavioral characteristic of elderly and adult based on the deep learning, here they are going to analyze the elderly people behavioral video. So they are taking all of the videos and they're segregating based upon the behavior. The age groups were segregated, so they have conducted over the average age of 77 years who perform like 55 behaviors, and they are classifying the age over the behavioral analysis. So generally from this, the conclusion is in most of the papers they have used the convolutional neural network, and more layers they have used, they can able to obtain a little bit more of accuracy. And here they have in all of the papers they have used a deep learning algorithm, and when the data is used for the training or testing model, the accuracy becomes higher, and the performance are increased based on like in augmenting the input. So these are all the conclusions from which the survey have been made, and based on this, the future work, a deep neural network can be implemented for the architecture to identify and analyze and classify the behavior of the human to produce a high performance and accuracy.
Already they have used a deep neural network, right?
Yes, ma'am.
Then your suggestion is also to go with deep neural network for
with more number of layers, ma'am. With more number of layers, and one more thing is that they have taken each and every layer to obtain separately. So here we can go for a combination of data, like spatial information they are using a separate model, and for the temporal information they are developing a separate model. So instead of like developing a separate model for each and every information, we can go for a combination of informations, ma'am.
So there are two takeaways then from this literature survey.
Yes.
They can go with hybrid data.
Yeah, ma'am.
Then they can try deep neural networks with more layers. This is what is your conclusion?
Yes, ma'am. And the input also, ma'am. The input they take.
Type of input.
Yes, ma'am. The type of input they take, based on that also the accuracy is getting, the performance is getting differs.
Performance differs.
Yes, ma'am.
These are the research issues you would like to bring
address.
out.
Yes,
address. Okay. Ma'am, I'm done.
Yeah. Okay.
Ma'am, any more questions for to the author? Panel members.
Yeah, this one more observation.
Yes,
in this paper, this a table can be included saying which feature is compared and how it is addressed. No, this table needs to be improvised further.
Okay, ma'am. Sure, ma'am.
You take a feature.
Okay, ma'am.
What are research issue and how it is addressed and what is the result in the particular paper, or is there a research gap in that paper? Like that you prepare. Any literature survey paper should have a comparison of all the existing literatures on different research issues, and finally you need to conclude some insights about the research issues and the future direction for the other researchers.
Sure, ma'am.
Adding to that, I think she can have a column where you can talk about the limitations of the existing works from which you can bring out some issues.
Yes, ma'am. Exactly.
Sure.
Yeah,
So
that's
these
what
three columns are not adequate.
Enough. Yeah.
Talk about one research issue and for this particular paper, whether that issue is addressed or whether there is a limitation with respect to that issue. Like that, please come out with the tabular column.
Sure, ma'am. Sure, ma'am.
Okay.
Sure, ma'am. I'll do that, ma'am. I'll take it as an extension from this. Thank you, ma'am.
Yeah.
Shall I stop presenting, sir?
Yes, ma'am. Yeah, stop
Thank you.
present.
Thank you.
Thank you so much, ma'am. Yeah, over to the organizers.
Do we have paper ID 25 with us, sir?
No, ma'am.
Okay.
We tried. We
Yes,
gave the two chances, and we
He's
couldn't
not
connect
there.
with them.
Okay, okay,
Yeah.
sir. Thank you. So,
Thank you.
on behalf of the organizing committee of ICCIDS 2022, I would like to thank the paper authors for submitting and getting the reviews from our reviewers. So I also like to thank the reviewers, and most importantly the session coordinator and the session chair for all the session chairs for evaluating the presentations and giving positive suggestions and scopes for improvements. So thank you so much for taking the time and evaluating the presentations. Thank you, ma'am. Thank you, sir.
Thank you.
Thank you,
Yeah.
Manisha.
Thank you, ma'am.
Thank
For
you all.
the session
Thank you all.
chairs and session coordinators, we have lunch arranged in the seminar hall. You are welcome. Please come. Thank you.
Thank you.
Thank you, Manisha.
Thank you, Sujadin.
Yeah, thank you so much.
Thank you,
ma'am.
Sujadin,
Yeah.
sir. Thank you.
ma'am. Yeah.
Thank you, all
Sujan,
participants.
Sir. Sujan, sir. Thank you, Sujadin.
All
sir.
the best
Thank
to
you.
all the
Participants,
authors of the paper.
authors.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am.